Welcome to our channel Learning Math. In this video, we're going to solve an extra problem in functions for grade 11. Now let's start together. Consider the function f such that f of x equals 2x cubed plus x squared plus 6x plus 1 all over x squared plus 1. Let C be the representative curve of this function in the orthonormal system OIJ. Now in part 1, find the domain of definition of f, then find the limits of f on the boundaries of this domain. Well, we have learned before in the previous video that whenever we have a fraction, this fraction should be defined if the denominator is different from 0. Note that x squared plus 1 is different from 0 for every x belongs to R. Why? If x squared plus 1 is equal to 0, then x squared will be equal to minus 1, which is impossible. We cannot trace any real number squared to get it negative equal minus 1. So x squared plus 1 is different from 0 for every x belongs to R. Therefore, this function is defined for every x belongs to R. So we can say that the domain of definition for f is equal to R. So it's equal to minus infinity sure opened plus infinity opened. Now what about the limits of this function on the boundaries of the domain which is R? We should see the limit at minus infinity and the limit at plus infinity for this function. Limit as x tends to minus infinity for f of x. Note that whenever we have fractions of polynomials, to find the limit for this function at minus infinity or plus infinity, we can just take the highest degrees for x on each of the numerator and the denominator. So its limit at minus infinity or at plus infinity is equal to the limit for 2x cubed over x squared. Now note that we can simplify x cubed by x squared. We get here x on the numerator. So it's equal to limit as x tends to minus infinity for 2x. X tends to minus infinity, then sure 2x will tend to minus infinity. The same for limit for f of x as x tends to plus infinity. We take the highest degrees for x on each of the numerator and denominator. So it's equal limit as x tends to plus infinity for 2x cubed over x squared. Also, we can simplify x cubed by x squared to get x, then its limit for 2x. When x tends to plus infinity, sure 2x will tend to plus infinity. Now determine the real numbers a and b such that f of x is equal to ax plus b plus 4x over x squared plus 1. In order to find f of x in this way, we need here to divide 2x cubed plus x squared plus 6x plus 1. We need to perform the division over x squared plus 1. Now let's start by this division. We write here the numerator and on the other side the denominator since we are dividing by x squared plus 1. Now let's see how to divide it. We start by the highest degree here, 2x cubed divided by x squared. Note that the coefficient here is 2 and here there is no coefficient as if it's 1. 2 divided by 1 is 2. And x cubed divided by x squared, x. We can just simplify it. So what is the answer here? 2x. After dividing, we should multiply. So we multiply the answer 2x by the divisor which is here x squared plus 1. Note that 2x times x squared, it gives us 2x cubed. Here plus times plus plus 2x times 1 is 2x. Now after multiplying, we need to subtract our answer. Note that our answer, 2x cubed minus 2x cubed is 0. We can write it or not. It does not affect. X squared, here we don't have x squared to subtract. Using algebraic expressions, we should have the same base and the same power. Here we have it x squared and here x. So x squared, we just copy it. Now 6x minus 2x, since we have here minus times plus minus. 6x minus 2x is 4x. So we write it plus 4x, the sign for the greatest. Now plus 1, we just copy it. Well, how to divide right now? We have to divide x squared by x squared. Note that x squared divided by x squared is 1. The sign is a plus since sure plus over plus is plus. So it's a plus 1. Now we just multiply plus 1 by x squared plus 1. When we multiply any term by 1, it remains the same. So we write it x squared plus 1. Now we can just subtract them. X squared minus x squared, 0. And note that also here 1 minus 1 is cancelled. What remains for us? 4x. Now how to write f of x? Note that 4x is no more divisible by x squared. Here the degree of x is less than the degree of x squared. So x is not divisible by x squared. Now how to write our answer? Actually f of x is equal to x plus 1 plus 4x over x squared plus 1. How did we get it? The quotient 2x plus 1, we write it here, 2x plus 1, the same. Plus the remainder 4x, we write it over the divisor which is x squared plus 1. So it's plus 4x over x squared plus 1. Well, if we refer back to the question, they are asking us to find a and b, so that f of x is equal to ax plus b plus 4x over x squared plus 1. Note that here the remainder is the same, 4x over x squared plus 1, 4x over x squared plus 1. Now what about a and b? The coefficients of x, if we compare them, should be the same. So 2 is equal to a. In this case, we write it a equal to. Now what about b? Plus 1 is the same as plus b. So we can deduce that b is equal to 1. Now let's continue. In this part, consider a equals 2 and b equals 1. Now show that the straight line D of equation y equals 2x plus 1 is an oblique asymptote to C. In order to prove that a straight line is an oblique asymptote to any function, we need to show that limit as x tends to plus or minus infinity for f of x minus y, the equation of this straight line, is equal to 0. Now let's find it. We have f of x is equal to x plus 1 plus 4x over x squared plus 1. Now what about limit as x tends to plus or minus infinity for f of x minus y? We used our answer, since we need now when we subtract to simplify 2x plus 1 by 2x plus 1. Note how do we solve it. F of x, we copy it the same. Its limit at plus or minus infinity. F of x, we copy it the same. And y, from the question we have it 2x plus 1. So it's minus 2x plus 1. Now we can expand or multiply by minus. So it will be minus 2x minus 1. Now if you note 2x minus 2x, so here 2x minus 2x is cancelled. And plus 1 minus 1 is also cancelled. What remains for us? 4x over x squared plus 1. So it's equal to limit as x tends to plus or minus infinity for 4x over x squared plus 1. Note that it's a fraction of polynomials. So we take the highest degrees of x since we are calculating the limits at plus or minus infinity. So we can write it equal to limit as x tends to plus or minus infinity for 4x over x squared. Also we can simplify x and x squared, we get x. Well, it's equal now to limit as x tends to plus or minus infinity to 4 over x. Note that when x tends to infinity, then 4 over x will tend to 0, even if x tends to plus or minus infinity. Well, now we have just proved that limit as x tends to plus or minus infinity for f of x minus y is equal to 0. Therefore, we can say that the straight line D having the equation y equals 2x plus 1 is an oblique asymptote to C. Now study the relative positions of C and D. Also, to study the relative position of a curve and a straight line, we need to subtract f of x minus y and study its sign. Well, f of x minus y, we have just solved it. We got 4x over x squared plus 1. Now we need to study the sign for f of x minus y. So we need to study the sign of 4x over x squared plus 1. We will see where it's positive, where it's negative. If you know something, x is raised squared, so it will be positive. Then sure, x squared plus 1 is positive. Well, sure it's positive for every x belongs to R. Now in this case, we can say that the sign of f of x minus y will exactly depend on the sign of 4x. If 4x is positive, then f of x minus y will be positive. And if 4x is negative, f of x minus y will be negative. Also, if you note, if 4x is equal to 0, then f of x minus y will be 0. Now let's see it. Sure, for x positive, we will have 4x positive. Then f of x minus y will be positive. In this case, we have the curve C will be above the straight line D. While if x is equal to 0, 4 times 0 will be 0. So f of x minus y will be 0. In this case, we have C intersects D. When the subtraction is 0, then we can say that f of x minus y equals 0, so f of x is equal to y. That's why we have C will intersect the straight line D. Now what about if x is negative? Note that when x is negative, 4x will be negative. In this case, f of x minus y will be negative, and since it's negative in this case, then the curve C is below the straight line D. Now verify that C passes through the point I having the coordinates 0, 1. How to verify it? Note that for x equal 0, we will have y equals f of x. So it will be f of 0. We replace x by 0. Note that if we replace x by 0 here, it will be 0. And this fraction will be 0. What remains for us? 1. Then y equals f of 0 equals 1. Note that 1 is equal to yi. So f of xi is equal to yi. Therefore, we can say that the curve C is passing through the point I, having these coordinates. Well, now we have another section in this part, and show that I is the center of symmetry to the curve C. How to prove that it's a center of symmetry? If we remember the rule, a point I having coordinates a, b is a center of symmetry to a curve when a is the center of the domain of definition to this function, and f of 2a minus x plus f of x will be equal 2 times b. b is the ordinate and a is the abscissa of this point. Well, if you know something, we have proved that the domain of definition for this function is equal to the set R. In this case, any point can be the center of symmetry of this domain, in particular 0, the abscissa of I. So we can say that a equals 0 is the center of this domain of definition. Now if you know something, let's calculate 2a minus x. A is 0, then 2a minus x is 2 times 0 minus x. 2 times 0 is 0, and 0 minus x is equal to minus x. Now if we want to calculate f of 2a minus x, then we just need to calculate f of minus x. We replace 2a minus x by its answer, which is minus x. Well, something else. Note that f of x is equal to x plus 1 plus 4x over x squared plus 1. To calculate f of 2a minus x, we just need to replace x by 2a minus x, which is minus x. So here, f of minus x, we just replace x by minus x. So it's 2 into minus x plus 1, we copy it the same, plus, and the fraction, we copy it the same, but on the numerator, 4 into minus x, and on the denominator, it will be minus x all squared plus 1, as you see here. Now we just expand them. 2 times minus x is minus 2x plus 1. We copy it the same. Here plus times minus is minus 4 times x. We write it 4x. Here minus x squared is the same as x squared plus 1. We copy it the same. Therefore, we have f of minus x is equal minus 2x plus 1 minus 4x over x squared plus 1. Now we can easily solve f of x plus f of minus x. How to calculate it? So f of 2a minus x plus f of x, we just replace them by their values. 2a minus x is minus x. We have proved it. Now we replace it by its value, which is minus 2x plus 1 minus 4x over x squared plus 1. Plus f of x, also we replace it by its value. Now note that minus 2x plus 2x is cancelled. And the whole fraction here, 4x over x squared plus 1, here 4x over x squared plus 1. Here is positive, here is negative, so we can simplify them directly, the whole fraction. Now what remains for us? Plus 1 plus 1 is equal to. Note that 2 we can write it as 2 times 1, 1 which is b, the ordinate of I. So it's equal 2 times b, therefore we can say that the point I having coordinates 0, 1 is the center of symmetry to the curve C representing the function f. Now in part D, we have the first part, part we can say it, show that f prime of x is equal to x to the power 4 plus 6 over x squared plus 1 all squared. Then we need to draw the table of variations for the function f. Well, let's write first f of x. We have proved it. Now we need to calculate f prime of x. If you note here, we have a fraction in this part. It's in the form of u over v. So its derivative, the derivative of u over v is u prime v minus v prime u over v squared. Well, note something, u prime, the derivative of 4x is 4 times v, which is x squared plus 1. So it's 4 into x squared plus 1 minus v prime, the derivative of x squared plus 1, which is 2x, times u, which is 4x, over v squared, x squared plus 1 all squared. Well, here we have solved the derivative of the fraction. Sure, the derivative of 2x plus 1 is 2. Derivative of 2x is 2, and derivative of the constant 1 is 0. We can write it or not. Now we just need to calculate them. Note that here 4 times x squared is 4x squared plus 4 minus here 2 times 4, 8, x times x squared. But if you know something, to continue solving, we can write 2 as 2 over 1. Also here, 4x squared minus 8x squared is minus 4x squared, the sign for the greatest. We can solve them together since we have same base and same power on both of them. Now 2 is 2 over 1. If you know to transform into the same denominator, since we have a plus, we can multiply both denominator and numerator by x squared plus 1 all squared. So we can say that f prime of x will be 2 into x squared plus 1 all squared minus 4x squared plus 4 over x squared plus 1 all squared. If you know something, x squared plus 1 all squared, we can write it as x to the power 4 plus 2ab, so it's 2 times x squared times 1, it gives us 2x squared plus 1. Well, note something. When we multiply them by 2, we will get it 2x4 plus 4x squared plus 2 times 1, which is 2. So f prime of x is 2x4 plus 4x squared plus 2 minus 4x squared plus 4, we copy it, and the denominator we copy it the same. Now if you note, 4x squared minus 4x squared cancelled, and plus 2 plus 4 is equal to plus 6. Therefore, f prime of x is 2x to the power 4 plus 6 over x squared plus 1 all squared. Note that it's positive for every x, belongs to R. Why it's positive? If you know something, we have x to the power 4 is positive since we have an even power. Then 2x power 4 plus 6 is positive. And here we have an even power, so it will be positive. Therefore, we can say that f prime of x is positive for every x belongs to R. Now, if we put the table of variations, x varies from minus infinity to plus infinity. F prime of x is positive. Then f of x will be increasing from the limit at minus infinity, which is minus infinity, towards the limit at plus infinity, which is plus infinity. Now verify that the equation of the tangent t to the curve C at the point A of abscissa minus 1 is y equals 2x minus 1. If you know something, the equation of the tangent is y minus y0 equals a into x minus x0. It's a rule to find the equation of a tangent. Well, the abscissa x0 is given minus 1. What about y0? Y is f of x. Then y0 is f of x0. So it's f of minus 1. We have given f of x. If we replace x by minus 1, we get f of minus 1 equals minus 3. Now what unknown we are still needing to find? A. The slope A is the derivative of f of x at x0. So it's f prime of x0, which is minus 1. So it's equal f prime of minus 1. We have just calculated f prime of x. Now we can replace x by minus 1. We get a 2 plus 6. Here minus 1 to the power 4 is 1. Times 2 plus 6. We write it over minus 1 squared, which is 1, plus 1, 2 squared. It gives us 4. Now 2 plus 6, 8 over 4. We get a equal 2. We can just replace x0, y0, and the slope a by their values. We get the equation of this tangent is y plus 3 equals 2 into x plus 1. Now if we solve them, note that when we expand, it will be 2x plus 2 times 1, which is 2, and plus 3 we can get it to the other side. It will be minus 3. Now plus 2 minus 3 is minus 1. Therefore the equation of this tangent is y equal to x minus 1. Note it's the same as they are asking us about. Now show that the curve C cuts the axis x prime of x at a unique point of abscissa alpha such that minus 0.2 is less than alpha and less than minus 0.15. We have just drawn the table of variation and proved that f of x is strictly increasing on R, which is from minus infinity to plus infinity. So it's strictly increasing. Also, it's continuous, not only strictly increasing. It's continuous and strictly increasing on R, and in particular on the interval from minus 0.2 till minus 0.15. Well, note something else. If we calculate f of minus 0.2, it will be approximately minus 0.17, which is negative. And if we calculate f of minus 0.15, it's approximately 0.11, which is positive. Or we can calculate the product of f of minus 0.2 and f of minus 0.15, which will give us a negative answer. Now in this case, we can deduce by intermediate value theorem that the function f admits a unique root alpha such that alpha is between minus 0.2 and minus 0.15. Now trace the curve C, the straight line D, and plot the points A and I. If you know something, it's strictly increasing from minus infinity. Here, it passes through the point A having the abscissa x minus 1 and the ordinate minus 3. It's increasing. It intersects here the x-axis at the root alpha, which is between minus 0.2 and minus 0.15. Here it passes through the point I, which we have proved the center of symmetry of the curve. Here what we are going to talk about. The point I is the center of symmetry of the curve. So here, when we draw the second part of this curve, it will be the symmetric, exactly the symmetric of the first part. Note that we have drawn it increasing in this case, then we continue it increasing, but the symmetry of the first part as you see in the figure. Something else. Here we have the straight line D, and here we have the tangent T. The straight line D, which is an asymptote to the curve, note that when we have x tends to plus infinity, it will be as the straight line D will be an asymptote to this curve, and also as x tends to minus infinity, the straight line D is an asymptote to this curve. Also, as you see, the tangent T is tangent to this curve at the point A having the abscissa minus 1 and the ordinate minus 3. Now, thank you for watching. If you enjoyed this video, please like, share, and subscribe for the continuity of our channel to support you by more and more information. With a great appreciation for your support. Thank you all.